Okay, so now let's do this one. Find the area inside. So I'm going to set up the integral only. Area inside this. So let's get a picture of what this is. It's a cardioid. So it's going to be 1 and 0 and 1 and down here. So quickly get the graphs by plotting a few points. Then I've got r equal 1, which is a circle centered at the origin. So radius of 1. So something like that. Okay. So what is the area I want? I want the area inside the blue and outside the red. Inside the blue and outside the red. That's this. Okay. So let's think about where this is at, and let's draw a sector. So sectors always start from the origin. So I want the sectors that go all the way out to here, right? So to just get the green, to just get this part here, I'm going to have to take the sectors that just go to here and take those away, right? So the basic framework is going to be 1/2 outside subtract inside, and then it's going to be d theta. Okay, so the curve that's on the outside, that's touching the outside of the sector here, is going to be the 1 minus the sine theta. The inside that I'm taking away is this red circle, right? The red circle, so that's going to be 1. And then where am I building sectors from and to? So just because of context, you know this takes 0 to 2 pi to go around. This takes 0 to 2 pi to go around. So it's not here, right? It's not anywhere in the 0 to pi. It actually starts where they intersect, which is pi, I'm pretty sure. Let's double check. So if I set 1 minus sine theta equal to 1, I get sine theta is 0, so that's 0, pi, and 2 pi. So 0 to pi, there's no sectors up here, so we can't use 0 to pi. I'm going to start here at pi and swing all the way over here to 2 pi. So pi to 2 pi, because of context, looking at the angles of where the shaded area is, pi to 2 pi is where I'm taking the area. All right, so let's look at inside both of these. So here I have r equals sine theta, so I'm going to draw it kind of large so we can see. So r equals sine theta looks like this, right? Okay. Then r equal cosine theta. Tried to get green here. There we go. Green cosine theta. Here it is right here, right? And they both are radius 1 circles. Okay. So inside both of them. So that's this area in here, right? I tried to get red. Let's get some other colored dots in here. Anyway, okay. So this area in here. Let's look at these sectors. So remember, the sectors are super skinny because it's the thetas that get small. So I've got those sectors that touch the blue, correct? Then I've got these sectors that touch the green circle. Okay, so this is not subtraction, but rather addition of sectors, because I've got sectors starting from the origin that go all the way out. They just happen to touch different curves. So to get the area of these black sectors, it's going to be 1/2, and that's going to be the blue curve. So that's sine theta squared d theta, and then plus 1/2, and that's going to be the cosine theta squared, squared d theta. Okay, so let's go back to the blue curve here. The blue curve here, where this is equal to 0, is angle 0, right? Angle 0 is where r equals 0, so that's there. That starts there. I'm going to find out where they intersect. So where do you think sine of theta is equal to cosine theta? That's going to be at the angle of pi over 4 that's in the first quadrant. So angle 0 to pi over 4 is the black sectors. Then I'm going to start building the red sectors at that angle of pi over 4. And then I'm going to be building them until this red graph goes, or the cosine graph, the green graph, goes into the origin. So when does this go into the origin? When does cosine of theta equal 0? Thinking about just what's keeping in the first quadrant here, that's going to be when the angle is pi over 2. So the angle is pi over 2. So this combined area gives me the area in both of the curves.